Hi, everybody. I think, we'll probably get started. We're only like 5 minutes over, so typical Greek time. I think we're good. So, Christos, you want to come start, since this is mostly your show?
Hello, and thank you for giving me the chance to participate and share our experience. So, let's talk a little bit of ourselves. My name is Christos Sotiriou, and I work as a principal architect platforms design in Vodafone. I've been an employee of Vodafone for the last 5 years, and my team has been responsible for building the DXL infrastructure in Greece, for which we are going to talk about in a minute. And right now I'm responsible for creating the design and implementation of a new cluster based on the TM4 MODA architecture. And
my name is George Andrianakis. So I've been with Red Hat like 5 years now, 5.5, and I've been working the last 4 years, I would say, on Quarkus, and we've been collaborating with Christos since like almost the first public release of Quarkus.
Yes, that's true, and we have been early adopters of Quarkus, and we migrated to Quarkus from SpringBoot. Let's talk a little bit about the current state of Quarkus before we dive deeper.
So let's do really quick, so Quarkus 3.0 was released last week. Now we have Quarkus 3.02 with bug fixes. So there's a bunch of new stuff here in Quarkus 3. I'm not going to go through much. The big changes are that we now use Jakarta 10 instead of Java E8, so you have a package change. The biggest, let's say, breaking change is probably that now we use Hibernate RM 6.2, but we have a tool that can update your applications automatically. So there's a huge number of new features, but let's just say the most important ones are the new Dev UI, like a management interface where you can run some, let's say, privileged things on a different port. You have Redis cast support now. You have an info endpoint. You have packed testing integration. And so there's new microprofile and Jakarta EE APIs. So that's like in a really, really quick way. What's new with Quarkus 3, right? And in case people were wondering, but we can answer that later in questions if you need.
So what we're going to do today is to share our experience in Vodafone Greece about switching from Spring to Quarkus, why we did it, and hopefully we are going to present some things that many people don't pay attention to when deciding what framework to use. Before we are able to do that, let's talk a bit about what the digital experience layer in Vodafone Greece is. It's actually, in short, it's the backbone of Vodafone's digital infrastructure, like the My Vodafone application and the website and many other REST APIs that external people are using. It is comprised of from 160 microservices, and it's rapidly growing. We are hosted on Amazon, and it served initially as an intermediate caching layer. We are going to see how it works in a minute. And we had two goals when we were developing and designing the DXL. First of all, it was sheer API performance. If anything took longer than 2.5 seconds to complete, we would consider it a failure and we would redesign it again. And that was going to be a big improvement, especially since some of the corporate infrastructure that we previously had took approximately 15 to 30 seconds to complete. And we have achieved this goal. And not only that, but we also have achieved inside the DXL almost 500 milliseconds of API latency. This is the average, actually. So if we want to, I'm not going to get into the technical details. There's going to be a presentation tomorrow about the DXL, but just to say a few things, the DXL is the middleware. It sits between the front end and the back end and the corporate back end that we have. Those are the large monoliths that we have been using for many years now. And in order to speed up data retrieval, we are streaming data from the corporate backend databases to Kafka, and from Kafka, some microservices take this data, transform it, and save it to MongoDB for later retrieval. So for fetching data, we are fetching data from the MongoDB databases, but when it comes to changing data, we are communicating with the corporate backend. So that's the flow of information. that we currently have, and this is how we achieve the sheer amount of performance that we have with the DXL. So since it is enterprise-oriented, because we need SOAP messages to be supported, therefore that's why we turned to Java. We also needed fault tolerance mechanics and an easy way to configure them. And of course, high throughput from each and every one of our microservices was the top priority. We had initially chosen Spring for our development needs, and we have grown increasingly worried over time with the amount of resources in terms of CPU and RAM that Spring demanded, especially in our pre-production clusters, because we have replicas of the production cluster 3 to 4 times. And we had been increasingly worried about the boot times, and we're going to see why this is important in a minute. So we took the decision at the beginning of 2019, after having undergone a deep technical analysis of the alternatives, Node.js, Golang, Micronaut, to go with Quarkus. And therefore we did, and something happened, just a short story, something happened in the early 2020 that solidified our decision to go with Quarkus. So we had some microservices still in SpringBoot, and we still do. And initially, I believe early 2020, we released a version of the application. It was a milestone version because it would be the first version of the My Vodafone application that would consult the digital experience layer for constructing the main screen, which was a heavy data-driven screen. And we needed to consolidate information from, I don't know, maybe it was 7 systems at a time. And there was one microservice that throughout the user's journey was being reused many, many times. Let's call that user information microservice. That's not a real name, but let's consider that it is. Let's imagine that it is. So we released the application to 50% of our users. The bars represent the maximum concurrent users that we were able to sustain. That's the blue bars. And the green line represents the average response times in response to the user load. So we see that once we released the application, we also released a campaign prompting the users to log in inside the application so that they can take advantage of the new features. And that's where we started having problems because this specific microservice started to be overloaded, and we scaled it up, we scaled it out, and we reached the point where we could sustain some load, but we weren't sure if we could proceed with releasing the application to the entirety of our users, because we had cluster unavailabilities because of that all the time. So the key thing is that it's not only because of throughput, it's also because of the boot times. Because by the times we were able to scale up to scale out to 12 replicas maximum. However, the boot times, which back then using Spring MVC were approximately 40 seconds with with everything loaded, database connections and Kafka, it took so much to boot that the replicas that were alive at this time were taken down by Kubernetes because of heavy load already. So we never ended up having a healthy cluster under much heavy load. So we rewrote this microservice to Quarkus. It took us approximately 2 working days. And we released it, and when we released it, not only that's on the 28th of January, and then we were able to see that we also released the application to the entirety of our user bases, and therefore, this is the graph that represents that no matter if the users increase, the concurrent users increase, we were able to drop the response times by a large margin. And not only that, we were able to scale in, to use less replicas in production, maximum 4 at the time, and use less resources per replica. So apart from the cluster's health, the cost savings were very important for us. So that's when we found out that we had already taken the right choice, and we decided to stick with Quarkus. However, it's 4 years later. And the reasons why we still use Quarkus also have to do with the developer performance, how the developers feel and use both frameworks when they build the business logic. And I believe it's time for Giorgos to do his magic. I'm going to...
Let's hope everything works.
Yep. Let's make a computer switch here.
So let's see. Hopefully everything's going well. Excellent. So like we hear a lot from folks that they start getting interested in Quarkus because like the performance in real world scenarios is very good compared to the alternative, right? But we increasingly hear exactly what Christos said, that people stay on Quarkus and get hooked on it because of the developer experience. And I'm going to try to show you, like in a very, very simple, almost hello world style example, what Vodafone has also said, that in a lot of cases, you write less code with Quarkus instead of Spring. And you can turn around, let's say, your business logic much, much faster. So what am I going to do here? Basically, I'm going to write the same application in Spring and Quarkus, right? So I'm using like almost latest Quarkus 3 and SpringBoot 3. And what I want to do basically is contact one REST API that's out there, like it's called REST Countries. RESTcountries.com. So this is an API that just gives you, oh, wonderful. Gives you information about, okay, no network here. So I'll have to switch to my phone and hopefully that works. Portable hotspot. Because I was on the network earlier and it worked in the other room. So let's see what we can do now. There's a bunch of networks. A bunch of networks here. I don't see mine yet. Christos Sotiriou's phone, that's good, but no, I got mine, thanks. So let's try this again. And okay, the 5G is great in here, so what I want to do is like consume this REST API from Spring and from Quarkus, right? Okay, so let's start like really, really quick. I have the model created, and in this particular example, I'm only going to use like the name and the country code, although there's a huge amount of information. And so the simplest thing is that let's just expose a dummy, right? So let's start. What does it look like to start a Quarkus application when I'm developing? And in this case, I'm going to use Maven, so it's MVN Quarkus dev, and this starts up Quarkus. For Spring, I would do MVN Spring Boot run. And for Spring Boot, I also have the developer tools configured in POM XML. In Quarkus, you don't have to do that. Like everything is just configured automatically without anything. Let's see if these both work. So I'm going to hit 8080. I get the dummy response from both, which is excellent. But now let's try to actually like get some real data, right? So in Quarkus, we've had since almost, let's say, the first public version, we've had the notion of the declarative client, right? So when I want to consume a REST API, all I do is declare an interface. I register as the REST client. I need to tell it like what configuration I'm going to use. So I'm going to use this country's API config key, which I've also configured in my application property. So with Quarkus, we configure everything in one unified way. So in this way, I'm just saying that the URL that I want to use is this one. This config key maps to that. And what I want to do essentially is that I am going to use a reactive way to return every single country in the world, right? And we're going to call this getAll. And this is a get method. And this is under the all path, and there's also a root path. So I want to use the latest version, let's say, of the API. So with Quarkus, all you do when you want to consume an API is that you declare an interface, you declare like what configuration maps to it, and you just write methods that map to the upstream API, right? The simple way to consume that is that I just go private final countries REST client. I'll call this, oops. I'll say this is client, and I'll have IntelliJ create the constructor for me. I need to add a CDI qualifier here, and I want to go in here and say, okay, client, get me all the countries. I want to make this, and with Quarkus, I'll just refresh. Hopefully, if I haven't made any dumb mistakes, everything should just work, right? Everything just works. So this retrieves me all the country. So to recap, I used a external API with almost zero code, right? So all I did is declare an interface, everything just works. And with live reload in Quarkus, I haven't configured anything, just hit refresh, everything is magic. Now let's try the same thing in Spring. So how many of you have used SpringBoot 3? Are using it? Well, that's a great amount, excellent. So for the folks who have used it or who want to use it, there's an awesome feature in Spring that basically tries to replicate the same experience that we've had in Quarkus for 4 years now. And you would do the countries REST client. Oh, actually, I messed up the name in the Quarkus version, but that's okay. So in Spring, you would say HTTP exchange. Again, you give it the root path. And you go here, and in the Spring world, when we want to use reactive stuff, we use the project reactor, so Flux, in this case, would return all countries. And you would say this is a get exchange, which again goes to all. But now here is where currently there is a big difference between Spring and Quarkus. Now, if I try to inject this into my controller, and I go private countries REST client, and I try to add the constructor, then IntelliJ complains that, you know what, there's no bean that is declared for countries REST client. And in the antithetical to the supposed Spring way of doing things, I have to configure things. So in the configuration in this case is not something anyone would want to write, right? So in order to get my client, I would say countries REST client, and this would be a bean. And now here's where the magic happens. So you have to say, I want to use an HTTP service proxy factory, which is like really easy to say, obviously. You use a builder. Now, a builder needs a client adapter, and the only client adapter that's available is the web client adapter, which the web client is in the Spring reactive world, how it's the programmatic way to call HTTP services. Now, I need to configure this client, so I'll go var client is web client, builder. I'll need a base URL, so I'll come back to that, and I'm going to build this, right? So I'll get the client here, and once I've done that, then I need to build this builder for this proxy factory, whatever, and once I've done all this, then I can actually get my bean for the client. I still haven't passed in here the URL, so let's say URL, and in this case, I'm only configuring a URL, so I can just use a string here and say countries URL, which I have configured in application properties, and I'll pass that here. And let's hope, like when I'll refresh, that things will happen. They happen too fast and they happen wrong, so obviously I made a mistake. So in Spring, even with the developer tools enabled, I have to make the project build somehow. So I have to remember to, in IntelliJ, tell it to build the project, right? So let's refresh. Okay, yeah, so I didn't change the actual code that uses this, client get all. I'll make this return what I want it to return. I'll remember to build this time, and I'll refresh, and something seems to have not gone well with the, oh, there we go. Yeah, so it's probably just a network problem. So now in Spring it worked, right? Same exact example, but in this case, I had to configure a whole bunch of things that aren't exactly obvious. And I would, in the real world, I would also have to like make a config object here, because there's probably a lot more things I want to configure than just the URL, like connect timeouts, request timeouts, things like that. I would have to write all that code manually. Now, in Spring's defense, like there is an open issue that says that, you know, we need to auto-configure this, because I'm sure they've seen what Quarkus does. And hopefully that will come, like maybe SpringBoot 3.1, 3.2, whatever. But this is a recurring pattern, and Christos had found this like 4 years ago, right? In the blog post they have, which we can detail later, they mention explicitly that in their case, there were a lot of features that required like 30% less code. So this is just like one very simple example. Now let's, I used the reactive stuff because I wanted to show like the one reason Vodafone wants to use this reactive stuff is because, for example, things like doing parallel REST calls become much easier than when you try to do them with like imperative programming, right? So if I use the API, the REST API from this service I'm using that gives me a country by name, and I want to get stuff like I want to get like stuff in parallel, then I would just say like, okay, if I haven't provided any names, like give me all of them. If I do want to provide names, then you know what, I have to go ahead and create a way to make these things happen in parallel. So I'm not going to go into the details of this, like we can talk about it, but it's not really like the point. This is basically reactive APIs, so people who know like Project React or RxJava or Mutiny and Quarkus, like they understand that what I'm doing here is like building a pipeline, and the important thing I'm doing here is like I'm limiting the concurrent calls to 5, right? This is just arbitrary. Obviously, I could have done more or less or whatever. So now I just want to make this into a list. And I'm going to say array list and list add all, right? So this is how I'm going to do concurrent calls in Quarkus, and I'm going to call it here. So basically what I didn't say earlier is that I've already passed the names here, but because I wasn't using them, like it was getting everything. Now it just gets Greece and Italy, and these are done in parallel. So
I would just like to.
Yeah.
I would just like to add to this specific example why it's so important, because if we remember, it's the sheer amount of API performance that we were looking at. So when you are looking for performance and you have so many different backend systems to consolidate and aggregate, having parallel calls is the most important factor for API performance. In fact, in all our microservices, we are trying to do everything in parallel unless there is sequential business logic.
excellent. So let's do the same thing in Spring very quickly. So it looks similar, but it's a little simpler because of the fact that we using Flux instead of a mono of list. But we can talk about why that is, but it's not like terribly important for the demo. Require false string names, and okay, I'm going to say if names is null or names is empty, like return me everything. Otherwise, return flux from iterable names and do a flat map. So I want to get everything, get by name, which I have not declared. So let's create that. Yeah. I'm not going to like that signature, so I'll use the real thing. Let's just do this, and get mapping will be very similar to what we had in the Quarkus version, and we're going to say this is a path variable. So now we have this, and we're going to just return it, right? So build project, so I remember Control F9, I refresh, and I got an error. Oh, this, yeah, I don't know. I can't read it, to be honest. Let's see. Excuse me? Oh, yeah, you're absolutely right. I didn't give it a name. Yeah, thank you very much. Oh, I refreshed, it didn't work because I'm used to Quarkus. I have to rebuild. And now it works, right? So, very similar experience, but I have like maybe 1 minute. I want to show how we would do continuous testing in Quarkus. So basically, like testing is super important, obviously, for developers. In Quarkus, we have a super cool way to do tests where I would just, let me start from the beginning. Like in this console, the Quarkus console, when I've run Quarkus dev, I have press R to resume testing. So let me do that. There are no tests found, right, because I haven't written any tests. But if I go to this like class that I had prepared earlier, and I say, make this a Quarkus test, and you know what, then go and test get all. And all I want to do is just make sure that this returns like 200, right? So I'm going to say when and get countries, then status code 200. And I don't have to do anything. I just like move to the terminal. You ruined my demo. No, I mean, that was the point, right? So I made a typo in order to show that the test automatically executes and it doesn't pass, right? So now that I have people better than me to actually show me what my errors are, I can go and correct them, go here, touch nothing else, just go back to the console, and the test reruns automatically and it just passes, right? I don't think I need to write this for Spring. Like I know you all know how to write this in Spring, and there would be no easy way. Let's say there is no actual way to have this continuous testing thing. I would have to like do SpringBoot test web environment blah 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 random port, and then like basically write the same thing and try to execute the test like from the IDE. Or from a separate terminal in Maven, right? And obviously when I update the test, it doesn't reflect, it doesn't rerun automatically. With Quarkus, the magic just happens, right? So there's more stuff I wanted to show, but I think that what Christos has to say is more important. But just to lead into what Christos is going to show, I'm going to run this application in production mode. Right, so I'm going to generate the jar for Quarkus. I'm going to generate the jar for SpringBoot, where I'm also going to enable AOT, right? So this is just a WebFlux application with AOT, so like almost the smallest thing you can get in Spring. So I'm going to run like Quarkus application on my machine. This starts in 0.7 essentially, and in Spring with AOT enabled, this will start in 1.3, right? So for hello world style, right, you have almost half the startup time. And as Christos mentioned earlier, like the larger the application becomes, the larger this discrepancy is. Also, last thing before I hand it off, is that we want to see the total memory that the Quarkus application uses. In this case, 121 megabyte. That's not heap. This is like entire memory of the Java process for Quarkus. For Spring, it would be 203. So about like 60%, something like that. But these are like just demo numbers. Christos is going to show you like real numbers. That's what you're really interested in.
Thank you very much. That was actually quite good.
Too fast.
Too fast, but I believe that it was very, very good, actually, and I hope that we'll be able to demonstrate the rest of the things that we want to demonstrate, because sometimes everything goes wrong at the last minute. So let me switch over to my DLJ. So what Giorgos has shown us is how Spring and Quarkus boot under using his computer. So what we are going to do is to put that inside Kubernetes, because SpringBoot and Quarkus are Kubernetes native. So what we're going to do this time, I see a lot of performance tests being conducted on host machines and even on the internet. But when we try to figure out if something is for us, at least in our case, we need to limit its resources to see how it behaves under a certain load. So what I have done here is that we have packaged the application that you just saw. Actually, it returns a dummy response. Both of them, Quarkus and SpringBoot. We have packaged it, and I have a micro Kubernetes installed, along with those two applications installed as well, Quarkus demo and Spring demo. I chose to use micro Kubernetes for various reasons that have to do with performance testing. And we have limited the use of both containers to 300 milli CPUs, that's 0.3 CPUs, and 300 megabytes of RAM, which is less than ideal. for, I believe, at least for Spring. And we're going to see how they behave under certain load, and we're going to use case 6 for that. So let me switch to iTerm. Okay, first of all, we are going to scale it down, both of them, to see the boot times. Okay, so both of them are scaled down, and now I'm scaling them up. So one note, I have allocated 4 CPUs to this micro-K test instance, and since we're using 0.3, then there is no problem running those together. They do not affect each other. So let's check the logs. So Spring took approximately 9 seconds.
This is for the same application, right?
This is for the same exact application. And Quarkus started in 3 seconds. And I have to point out, for everyone that is following the Quarkus road, that I have been very careful to remove any JVM optimizations that Red have done in their default Docker file. So I use the same Docker file for Spring and Quarkus and the plain JVM. So right now that we have this, let's make a port forward. I'm going to put, let's make a port forward. I'm going to put Quarkus on port 8090, and I'm going to put Spring on port 8080. And we have 2 scripts here for load test. One is Quarkus that hits the dummy response in this port, and the other is Spring. And we are going to simulate it with 3 virtual users as if they were trying to hit it as fast as they can. Can I put this on the bottom? Okay. So, Okay. So let's start and see what happens. Case 6 is the case 6 Quarkus, and here is case 6 Spring. So let's see what happens. Okay, this is going to hit it for 1 minute, and during this 1 minute, I have to point out that why we are doing this. There are some people that are going to say now, okay, but they're not warmed up. This is exactly the point for me. The point is not to measure anything, something when it's warmed up, but since we are measuring boot times and performance, and in order to test the resilience of the cluster, we need to be able to identify how fast the microservice reaches its maximum throughput, and how fast and how it behaves during the first few calls or the first few minutes since it's booting.
Which is the problem you had initially, right?
Yeah, that's actually the problem that we had initially. And the test isn't complete yet, but you can see the difference right here. Let's wait a few seconds more. Okay, that's the difference. 385,000 calls were made using in the Spring stack, and 130,000 calls using SpringBoot. Now, if I using Quarkus. 100,000 calls using Spring.
Okay.
And 385,000 using Quarkus. So let me continue where we left off. And let's explain a few things about why we did the test we did. And of course, we don't have time to run extensive performance tests with both applications warmed up. But those are some tests that I believe that we can publish them after the event, along with the code. The thing is that we see that in restrictive environments, Quarkus performs much better. Apart from the boot times, it also has a much higher throughput. Now, if you throw more resources into the mix, like giving 1 CPU and a gigabyte of RAM, the gap is narrowing. Still, still Quarkus is ahead, but the gap is narrowing. What's more interesting is with the performance tests between the cold up and the warmed up app, is that the gap between the cold and warm in Quarkus is much lower than the gap between the cold and warmed up application in Spring.
So you're saying that the Quarkus application reaches its maximum throughput much faster? Okay.
Yeah, it's much faster. And probably this has something to do with the optimizations that Quarkus is able to do during the compile time. And this is why we wanted to show this. So that's... let's talk a little bit about some notes that we have about performance in general. When we're talking about performance, especially in Kubernetes environments, we need to be able to see how a microservice works in as close to the production as possible. And of course, in Kubernetes environments, you will almost always, actually always limit the resources that your pod will consume. And you should do that because Kubernetes always makes better decisions about scheduling your pods, scheduling the workload, scheduling how many requests each pod will have based on those factors. And the more deterministic you are about your resource consumption, the better Kubernetes will behave on your pods. This is why we wanted to run those tests in restricted environments and with limited resources. Now, the more you are, the slower it gets. This is true for both, but in our experience, since Quarkus does many compile time optimizations, you can add much stuff to Quarkus and still have lower performance impact than SpringBoot, especially in situations when during the boot of your application, the microservice needs to perform many operations such as connecting to databases, Kafka messages, and stuff like that. Okay, and just for being totally transparent, the numbers that for 2019 were based on Spring MVC, non-reactive version, and the Quarkus non-reactive version, because there wasn't any REST reactive there. This is why the numbers that you see here are totally different, because both of those we used in those frameworks, for both of them, their reactive counterparts.
Yeah, so we're pretty much out of time, so let's...
Okay. So the thing is that using Spring, you may have something like this in your cluster, and using Quarkus, you may have something like this. So the cluster is more dense, more microservices in the same amount of space. And not only that, but you are able to scale from the cluster as it seems in low traffic hours in a much lower time than with Spring. You can scale that into 7 seconds compared to 40 seconds or a few minutes with SpringBoot. So developer experience, we wanted to say a few things. Yeah, we love it, but should we jump here?
Well, I just want to say, because we're out of time, like we could talk a lot about it, so anyone that has questions, like, reach us later on. But the thing that I also didn't have time to show in the demo is that Quarkus really makes everything work in reactive in the exact way you expect it. For example, if you tried to do in Spring Web Flux, if you tried to write middleware that tries to inject headers somewhere, right, with auto-wired, that just doesn't work. In Quarkus, everything you do in non-reactive mode and reactive mode is fully integrated. It just works. With Spring MVC or Spring Web Flux, you will hit a bunch of issues like you did, and unless you really know what's going on under the hood, you just can't make sense of this stuff.
Yeah, Quarkus will most of the time make the correct decisions about which thread pool it's going to run your workload on, and if it's going to use the reactive or the non-reactive counterpart. You can override this, of course, but you rarely do. For example, we use we use Hibernate with Quarkus, the plain Hibernate with the REST reactive, and it just works. No problem whatsoever.
Yeah, so I think, we're just going to skip native for now. We don't have enough time. So this is a bunch of Quarkus and Vodafone talks that if you want to learn more, I've sorted them here. Actually, Clement sorted them for me here in the time from now till tomorrow. So you have stream processing for Quarkus now, first talk, and then a bunch of other Quarkus talks. And tomorrow you have a deep dive into the DXL journey, right? So if you want, just take a photo of this. You want to learn more. Any questions you have, you can ask us as we're going out, because we need to clear the room. You guys have to get coffee and everything. So,
yeah.
So thank you very much.
Thank you.